Hello dear friends and viewers, welcome once more to my YouTube channel. Okay, well, in today's video I'm going to talk about resistors being connected in parallel and in series, and then in the next video, or surely in this one video, we're going to talk about currents and voltage divider rule. Well, to begin with, we're going to start with the with the resistors in series. I'm going to talk about the voltage divider rules. Well, like I already mentioned last time, when the two resistors are connected in series, they have the same voltage, the same current and different voltages. So like you can see in the circuit which we have here, this circuit here, we have two resistors. This is resistors R1 and R2. Let me just label it. R1, R2. Yes, these two resistors R1 and R2 connected in series. So the current which you're going to flow to them is the same. Now, we know from a Kirchhoff voltage law that as we're moving into this loop, the EMF, which is the voltage supplied, is equal to the PD. According to the Kirchhoff voltage law, that is the voltage throughout the loop, is the sum of all voltages is going to be equal to 0. So, equating V equals to I times all, that is the same current flowing at multiplied by the sum by the total resistance. Okay. Now we know that V1 is equals to IR1, that is the voltage through the resistor R1, is going to be the current flowing through it, which is I, times a resistance, which is R1, and the voltage, I didn't label it correctly. Here is supposed to be 1, and here is supposed to be 2. Okay, so the voltage in V1 is equals to the current flowing through it and the resistance, and same goes for the voltage through R2. Okay, guys. Now, according to the Kirchhoff voltage law, we're going to have voltage equals to I times R1 plus R2. But since I is identical, so it's going to be R1 plus R2. Now, in this case, I is equals to V divided by R1 plus R2. And now, we know the total voltage in the whole circuit is going to be the current, that is the current through the whole circuit, times the combined resistance. Now from this equation, let me just call this equation 1. From this equation 1, if we make V the subject, since V is already the subject of the formula, you know realizing that this R1 plus R2 is equal to Req, and Req is the combined resistance. So what does this tell us? This tells us that when two resistors are connected in series, the combined resistance is simply the sum of the value of each resistor. So when two resistors are connected in series, the value of the combined resistance is the value of each resistor, just adding. So Req is equal to R1 plus R2 plus Rn. Now, let's talk about how this is related to the voltage divider rule. Since when connected in series, they will obviously have different voltages. Okay, you can see here that V1 is equal to I1 R1. But we don't know the value of I, and we know that the current when they're in series is the same current. And we know I is equal to V divided by R1 plus R2. So once you substitute this in this formula, that this is V1, this tells that V1 is equal to, first of all, we're going to have, you just simplify everything. We're going to have R1 divided by R1 plus R2 multiplied by, okay. Before we take an example, I think it's better to talk about resistors in parallel and a bit about the current divider rule. Okay. Now we already know that, like I mentioned in the last tutorial, that when the two resistors are connected in parallel, the voltage through the resistors are the same. And we know voltage from Ohm's law is IR. So the current flowing through R1 is I1, the current flowing through R2 is I2. So voltage here and here, since the voltage are the same, we're going to give it a same value of V. So this tells that V is equal to I1 R1 equals to I2 R2. Okay, so and we know that I1 is equal to V on R1 and I2 is equal to V on R2 from this formula using Ohm's law. Now, from Kirchhoff current law, you will see that this current here ends up dividing after passing this node. It divides itself and take two paths. Okay, but like I told you last time, this is the easiest way you can know if two resistors are connected in series and in parallel, that by seeing where the main current comes from, how is the current flowing between the two resistors? Is it moving in the loop, or was there separation from the main source? And you can also see here that they are connected in the same node. They are connected to two single nodes, this and this. Okay, well, so I1 is equal to V on R1, and I2 is equal to V on R2. And we know from Kirchhoff current that I is equal to I1 plus I2. So now, we substitute values of these values here. We'll have this, and this simplification will give us 1 on R1 plus 1 on R2. All that multiplied by V, since the voltage in the whole circuit is the same. So now, but we know that the total current flowing through the whole circuit is I, is given by the voltage divided by the total resistance. That's the voltage in the whole circuit divided by the resistance of the whole circuit. And when you end up having I is equals to V on RQ. But you see here that you have this I here. I is equals to this. That is the reciprocal of R1 and R2 times V. So what does this tell us? This simply tells us that, and we know that, well, we just need to simplify by removing the V on both sides. So we end up having 1 on RQ is equals to 1 on R1 plus 1 on R2. That is, the reciprocal of the combined resistance is equal to the sum of the reciprocal of respective resistance of each resistors. So in this case, if we add plenty of resistors, will be 1 over R plus 1 over R1 plus 1 over R2 plus 1 over Rn. In this case, you have to use the LCM so that you look for the value of RQ and the reciprocal of RQ. And now, for the current divider rule, just like instead of the like in the case of voltage divider rule, here we are going to have, if we're looking for I1 here, it's going to be R2 divided by R1 plus R2 multiplied by I. And if I was going to look for I2, it's going to be R1 divided by the sum of the resistors times the current. And if there were two resistors, like and we're looking for R2, the current in R2 will be R1 plus R. So R1 times R3. Well, let's take some examples. Well, these are two examples here. I'll have to look at it clearly, and I will give you a little assignment. Try and identify which resistors are connected in series and which are connected in parallel. Well, I guess you don't know that. First, you need to identify which one are connected. When you identify two pairs, you give my two resistors first to make it easy. Identify, and you ask yourself, are those two resistors in series? Yes. Or either in series. Is any of them in series or in parallel with another resistor? And how is the next resistor connected to another one? But another thing you should need to know is that you see you have an open circuit, which shows that the supply was coming from this other side. So you begin analyzing further away from these points. So in this case, we begin analyzing from the feed home resistor. Now you go like this, you end up seeing that the feed home resistor is in parallel with the 1 ohm resistor, and this is in parallel with one. Oh, sorry, in series. Yeah, these two are in series, and you see that these two are in parallel because they have this one node and this other node here in common, and the combined resistance will be in parallel with this guy. Okay, and this from here we're going to have these combined resistors of all will be in parallel, and in parallel they will be in series with one of these. And from there, you just need to add to obtain the total resistance. So we're going to solve this and see how it's going to look like. So analyzing the circuit in the same way as we analyzed the previous one. You see this 5 ohm resistor and this 1 ohm resistor are in series. So 5 plus 1 is equals to 6 ohm. And now, try and look at this point. You realize that there's a certain node here, if you observe keenly, and there's another node here. This one, and these two resistors are also connected to this node. So we know about the resistors being connected in parallel, and there's also this other node here and this node here. These two resistors 4 and 12 are connected to this node, and also connected to this node as well. So we have 6 in parallel with 3 equals to 2 ohm. We have 12 in parallel with 4, which is equals to 12 times 4 divided by 12 plus 4 equals to 3 ohm. And in this case, we need to redraw the circuit. So 6 in parallel with 3 equals to 2 ohm. And 2 is in series with 1 equals to 3 ohm. Okay. Now 3 is in parallel with 2, because if we redraw the circuit, I want to have this. Three and 2 ohm, and this 10. So this 3 parallel with 2 equals to 1.2 ohm, and now the total resistance will be ROE equals to 10 ohm plus 1.2 ohm, which is equals to 11.2 ohm. Okay guys, that's all for electric loss. See you in the next video.